Hey there fellow Factorians, Onerous here with another tips and tricks video for Factorio. And in this video we are talking about math in Factorio. I want to preface this by saying you don't need to know any of this. Math in Factorio is all about min-maxing. In reality, you can just keep building materials, you can keep building your factory more and more to supply everything you need to launch a rocket. In saying that, people, myself included, like to sort of work out nice ratios of things that we need, how many assemblers we need to make X amount of red science per minute. And that's just one of the challenges that we set ourselves. And if you're watching this video, then you probably are similar to that as well. And just looking for a little bit of info. And, well, the simplest thing we need to know is how long something takes. And here is the basic formula. The information we get given in game is crafting time, how long something takes to craft, and the crafting speed of whatever it is you are crafting with. So that's the assembly machine or the chemical plant. And simply crafting time divided by crafting speed tells you how long something is going to take to craft. There are times when you want to know how long something will take to craft, but in general what you really want to know is how many units you'll produce per second. Because one of the biggest places that we use math in Factorio, of course, is when we're looking at science. And if you're chasing a megabase, you want to be producing 1,000 science per minute, or maybe you're just having a target of 60 science per minute, which is 1 science per second. So if you want to know how many units per second, it is just the inverse of what we had before. It is crafting speed divided by crafting time. So let's see that in action, shall we? Let's pop down little assembler here and throw in probably the first thing you'll want to actually care about math in, which is a red science. I'll point out here that I'm playing in creative mode. We've just got a few things set up here, so infinite power in like a huge area, infinite robots, all these items. You don't need to worry about that. It still just allows me to plop stuff down and explain things quickly. So back on our formulas, we see a red science or automation science pack takes 5 seconds to craft. If we hover over our assembly 1 machine and right down the bottom of the info panel on the right, we see crafting speed of 0.5. So if we look at our units per second crafting speed of 0.5 divided by crafting time in seconds of 5 gives us units per second, which in this case is 0.1 units per second. So this guy is producing 0.1 units per second. Say we want to be doing 1 science per second. We're pushing for 60 science per minute. If this is producing 0.1 science per second, we will need 10 of these. So 1 divided by 0.1, 10 machines to produce 1 science per second. If we want to produce 1,000 science per minute, which is 16.6 recurring science per second, we would need the 16.6 divided by 0.1, which is obviously 166. So obviously this is an assembler one, and you're not going to be using this to produce 1,000 science per minute, but the ratios still remain the same. And as things get more complex, and well, before we step on, the next thing that often trips people up is how many subcomponents do I need? So to produce automation science packs, you need copper plate and iron gear wheels. Now most people will have some kind of smelting array that's just pumping out tons of copper plate, but all of a sudden you're only producing iron plate and you want to know, how many iron gear wheel production units do I need? So the thing is here, you can have a look at this and go, well, this is producing 0.1 automation packs per assembler per second. I'm going to need 0.1 iron gear wheels per assembler per second. that's there's a shortcut, and the shortcut is just looking at how many of these we want to produce. So I want to produce one of these a second. That's my goal, 60 science per minute, 1 science pack a second. Guess what? That's just going to need 1 iron gear wheel a second. Now, sure, we have to build 10 of these to actually make that happen. There's 5, there's 10. But all we need is 1 iron gear wheel. And all we need is 1 a second. So this is taking 0.5 seconds to produce with a crafting speed of 0.5. So 0.5 divided by 0.5, yes, it's 1. So this produces 1 iron gear wheel a second. So this will be enough to feed all of these guys, because yes, if we think about the math in detail, each of these is using 0.1 a second. So times 10 is 1. But the quick way is just I want to produce 1 of these a second. I need 1 iron gear wheel a second. I need 1 copper plate a second. Now, that seems really simple, and it is. But of course, that is just red science. Let's have a look at green science, which is the next level up. And I've gone to assembly machine 2 here just to make things even more difficult. Alright, we want to produce 1 of these a second. This takes 6 seconds to produce, and our crafting speed of an assembler 2 is 0.75. 0.75 divided by 6 is 0.125 a second. So 1 of these is producing 0.125 units a second. We want to produce 1 a second, so 1 divided by 0.125 is 8. With 8 of these guys, how many is that? 6. With 8 of these guys, is that 8? Yes, it is. 8 of these guys, we are now producing 1 green science a second. But green science needs inserters and it needs transport belts. How many of these do we need? Oh my gosh. Again, simplify it massively. We're producing 1 logistics science pack a second. We want 1 transport belt a second. We want 1 inserter a second. So we come over here, we go inserters and transport belts. Transport belts produce 2 transport belts per 0.5 seconds. And this is where things start to get a little bit more complex, because we have, instead of just 1 unit per second, it's actually 2 units per production. So with a crafting speed of 0.75, we go 0.5 divided by, 0.75 divided by 0.5. No, hang on. I've confused myself. Let's go back to the basics. Units per second. Crafting speed divided by crafting time. Alright. Crafting speed, 0.75 divided by crafting time, 0.5. 1.5 is how many this is producing a second. But that's 1.5 productions per second. So we need to multiply that by 2, because every time it produces 2. So this 1 unit is producing 3 transport belts a second. Easy. Likewise, the inserter, we don't produce 2 this time, so it's just 0.75 divided by 0.5, which is 1.5 a second. Now, we only need, and we're only using 1 inserter a second. So even though this is producing 1.5 a second, we don't need to produce 1.5 a second. We only need to produce 1 a second. So to actually get the right amount of materials for this, we only need 1 iron plate, 1 iron gear wheel, and 1 electronic circuit a second. Yeah, it's a little crazy, because if you're producing that with this arrangement, you're actually only, like, inherently you think, well, I'm only getting 0.75 a second because the crafting speed and the crafting times, but again, just keep it simple. Focus on how many you need and then how much materials you need for that. So here, if we just produce 1 iron gear wheel a second for this, because we need 1 inserter a second, we need 1 transport belt a second, so we need half an iron gear wheel a second here, because again, we're producing 2 2 with everyone here, but overall we only need 1.5 iron gear wheels a second. So we could get away with one of these because, again, crafting speed of 0.75 means this is producing 0.75 divided by 0.5, 1.5 a second. So something like that, obviously with iron plate and let's not forget electronic circuits, it just keeps getting bigger and bigger. Of course, you end up with some lovely stuff like this. This is yellow science from a blueprint that I did for my There Is No Spoon run recently. Yeah, things can get pretty complicated, but as long as you just keep those basics in mind, the math actually isn't that bad. All you need to remember is crafting speed divided by crafting time is units per second. The asterisk there is to remember that this is actually productions per second. So if you have 2 units per every production, you will actually have to double that. Not something to worry about when you're starting out, and as you get along, you just get used to the math. So, look, I hope that's been handy. It's not the easiest thing to explain over the video, but hopefully I've imparted some kind of understanding. And I think the biggest thing for me to remember is just that simplification of knowing if I'm going for 1 green science a second, I only need to supply 1 transport belt per second to no matter how many assemblers it takes to create that array for 1 green science a second. I only need to provide 1 transport belt per second and 1 inserter per second. Whew, well, that was some pretty heavy stuff, and I hope you got something out of it. Next time, I'm going to be starting a new playthrough. Probably a Death World is my plan at this point, because we just finished our There Is No Spoon run, and successfully, I might add. It was quite fun, but we basically min-maxed the biters a little bit and never saw one in the whole run. Even though they were definitely enabled, they were a long way away and never got near us. So to counteract that, I thought, why not go the exact opposite? And yes, we will see. I'm looking forward to it, and if you are too, I hope to see you there. So thanks for watching, and see you next time.